Have you ever wondered how Google Maps finds the fastest route so quickly? It's not just magic or guesswork. Behind the scenes, complex algorithms analyze real-time traffic data, historical traffic patterns, and even user-reported incidents to calculate the most efficient path to your destination. This process happens in mere seconds, thanks to the power of data structures and algorithms, or how Netflix recommends movies you might actually enjoy. Netflix uses sophisticated recommendation algorithms that analyze your viewing history, preferences, and even the time of day you watch certain genres. By comparing your data with millions of other users, Netflix can predict what you might like to watch next with surprising accuracy. The answer lies in the fascinating world of data structures and algorithms. These are the building blocks of computer science, enabling efficient data storage, retrieval, and manipulation. They are the unsung heroes that make our digital experiences seamless and intuitive. These might sound like intimidating computer science terms, but bear with me. Imagine trying to find a book in a library without any organization. It would be a nightmare, right? Data structures and algorithms provide that organization, making it easy to find what you need quickly and efficiently. They are the invisible forces shaping our digital world, and understanding them can be your secret weapon. Whether you're a developer, a tech enthusiast, or just a curious mind, grasping these concepts can open up a world of possibilities. This isn't just about lines of code, it's about solving problems in elegant and efficient ways. Think of it as a form of digital craftsmanship, where the right tools and techniques can make all the difference. Think of a master chef who organizes ingredients in a specific way to prepare a delicious meal quickly. The chef knows exactly where everything is and how to use each ingredient to its fullest potential. This level of organization and efficiency is what data structures and algorithms bring to software development. That's what data structures and algorithms do for software. They help developers organize and manage data in ways that make applications run faster and more efficiently. Without them, even the simplest tasks could become incredibly complex and time-consuming. They are the recipes and organizational principles behind the apps and websites you use every day. From social media platforms to e-commerce sites, data structures and algorithms are at the heart of it all, ensuring that everything runs smoothly and efficiently. So the next time you marvel at how quickly Google Maps finds your route or how accurately Netflix recommends your next binge watch, remember the invisible force at work: data structures and algorithms. Let's break it down. Data structures are like containers we use to store and organize data in a computer. Imagine a library. Books are arranged neatly on shelves, categorized by genre, author, and title. This organized structure makes it easy to find any book quickly. Similarly, data structures provide efficient ways to store and retrieve information. We have arrays, which are like numbered boxes holding data in a sequence. Linked lists are like chains of data, where each element points to the next. Trees, graphs, these are all different ways to organize data, each with its strengths. Now let's talk about algorithms. These are like step-by-step instructions or recipes for solving problems. Think about sorting a deck of cards. You could shuffle randomly, but that would take ages. Algorithms give us clever strategies to solve problems like sorting data, searching for information, or finding the shortest path, all done super fast. Efficiency is key in the world of algorithms. We measure this efficiency using something called Big O notation. Don't worry, it's not as complicated as it sounds. It's just a way to describe how the performance of an algorithm changes as the amount of data grows. Here's the exciting part. Data structures and algorithms are everywhere. Social media feeds use them to personalize your experience, showing you posts you're most likely to enjoy. Search engines rely on them to deliver relevant results from billions of web pages in milliseconds. Even online dating apps use algorithms to match compatible partners based on preferences and interests. From the moment you wake up to the time you go to bed, you're interacting with applications powered by these clever concepts. Imagine a world without organization, a chaotic mess where finding anything is nearly impossible. Sounds frustrating, right? In the realm of computers, data structures bring order to that chaos. They are the invisible organizers, the unsung heroes that make our digital lives manageable. Think of data structures as specialized containers for data. Just like you wouldn't store your clothes in the fridge, different types of data benefit from different storage methods. And that's where the beauty of data structures comes in. They provide efficient ways to store, access, and manipulate data based on the specific task at hand. Let's start with one of the simplest yet most powerful data structures, the array. Imagine a row of mailboxes, each with a unique number. That's essentially what an array is, a collection of elements stored in contiguous memory locations, each identified by an index. Arrays are great for storing and accessing data sequentially. Need the fifth element? No problem, just access it directly using its index. This makes arrays incredibly efficient for tasks like storing lists of items representing matrices in mathematical calculations or even handling image pixels. Now imagine a treasure hunt where each clue leads you to the next, forming a chain that ultimately guides you to the treasure. That's the essence of a linked list. Unlike arrays, which store elements in contiguous memory locations, linked lists connect elements using pointers. Each element in a linked list, called a node, contains not only the data but also a reference or pointer to the next node in the sequence. This dynamic structure allows for efficient insertion and deletion of elements, making linked lists ideal for applications like playlists, browser history, and even undo-redo functionality in software. Section 4, Trees and Graphs. Branching out and connecting the dots. Arrays and linked lists are great for linear data, but what about hierarchical relationships or, complex networks? That's where trees and graphs come in. Imagine a family tree. You have parents, grandparents, siblings, cousins, all connected in a hierarchical structure. Trees, like our family tree example, represent hierarchical relationships with a root node branching out into child nodes, and so on. Graphs, on the other hand, are more general. Think of a social network where each person is a node and connections represent friendships. Graphs excel at representing complex relationships between entities, making them invaluable for tasks like social network analysis, route planning, and even recommendation systems. Section 1, Algorithms, the recipe for problem solving. We've explored the world of data structures, the containers that hold our digital information. Now let's dive into the exciting realm of algorithms, the step-by-step instructions that breathe life into our data, transforming it in countless ways. Imagine you're baking a cake. You wouldn't just throw all the ingredients together randomly, hoping for the best. You'd follow a recipe, a precise set of instructions to ensure a delicious outcome. Algorithms are like those recipes. Section 2, Sorting Algorithms, getting things in order. Let's start with a classic sorting algorithms. Imagine a deck of cards scattered randomly on a table. Now, picture yourself arranging them in ascending order, perhaps by suit and then by rank. That's essentially what sorting algorithms do. They arrange data in a specific order, from simple bubble sort, where adjacent elements are compared and swapped, to more sophisticated quick sort and merge sort. Sorting algorithms employ clever strategies to tackle this fundamental task. They power everything from organizing search results by relevance to arranging playlists alphabetically, all in the blink of an eye. Section 3, Searching Algorithms, finding needles in haystacks. Ever lost your keys and frantically searched for them? Imagine having to search through a giant haystack for a tiny needle. That's the challenge searching algorithms tackle, but in the digital world where data can be massive. Linear search, the simplest approach, involves checking each element one by one until the target is found. Binary search, on the other hand, takes advantage of sorted data, repeatedly dividing the search space in half, making it incredibly efficient for large data sets. From finding a contact in your phone to searching for information on the web, efficient search algorithms are indispensable. Section 4. Big O notation, measuring efficiency like a pro. Now, how do we compare the efficiency of different algorithms? This is a crucial question in computer science and software development. When we write code, we want it to be as efficient as possible, especially when dealing with large data sets or complex operations. Efficiency can mean the difference between a program that runs smoothly and one that grinds to a halt under heavy load. That's where Big O notation comes in. Big O notation is a mathematical concept used to describe the performance or complexity of an algorithm. It provides a high-level understanding of the algorithm's efficiency by focusing on its behavior as the input size grows. This notation helps us abstract away the details and focus on the big picture. It's like a secret language computer scientists use to talk about how an algorithm's performance scales with the amount of data it handles. Imagine you're trying to sort a list of names. If you have just a few names, any sorting method might work quickly, but what if you have millions of names? The efficiency of your sorting algorithm becomes critical. Big O notation helps us understand and predict how different algorithms will perform as the size of the input data increases. Don't let the fancy name intimidate you. It's simply a way to express how the time or memory an algorithm requires grows as the input size increases. For example, an algorithm with a time complexity of O(n) means that the time it takes to complete its task grows linearly with the size of the input. If you double the input size, the time required also doubles. On the other hand, an algorithm with a time complexity of O(n)² means that the time required grows quadratically. Doubling the input size would quadruple the time required. We're talking about whether an algorithm takes twice as long with double the data, or 10 times as long, or even worse. Understanding these differences is crucial for optimizing performance. For instance, an algorithm with a time complexity of O log n is much more efficient than one with O(n)² for large data sets. This knowledge allows developers to make informed decisions about which algorithms to use based on the specific requirements and constraints of their projects. Understanding Big O notation helps us choose the most efficient algorithms for the job, ensuring our programs run smoothly, even with mountains of data. By mastering this concept, you can write code that scales well and performs efficiently, no matter how large the input size grows. This is a fundamental skill for any programmer or computer scientist, and it can make a significant difference in the success of your software projects. So dive into Big O notation and start measuring efficiency like a pro today. Section 1. The digital architects. Remember those impressive structures we talked about: arrays, linked lists, trees, and graphs? They're not just abstract concepts confined to textbooks, they are the very building blocks that software developers use to create the digital world we interact with every day. These structures are the invisible architects behind the scenes, ensuring our digital experiences are smooth, efficient, and engaging. Think about your favorite social media platform. Behind those seemingly effortless news feeds and friend suggestions lies a complex network of users, posts, and connections. Graphs are essential for representing these relationships, allowing the platform to determine which posts to show you, who to suggest as friends, and even how to target advertisements. Ever wondered how a simple post goes viral, spreading like wildfire across social media? It's not just luck, it's algorithms at work, analyzing data at lightning speed. These algorithms track how users interact with content, likes, shares, comments, to identify trending topics and predict what might capture the attention of a wider audience. But it's not just about entertainment. Social media platforms also leverage data structures and algorithms for more serious purposes, like identifying and mitigating the spread of misinformation. By analyzing patterns of sharing and engagement, these platforms can flag potentially harmful content and take steps to prevent its wider dissemination. Imagine navigating a bustling city without a map or GPS. Overwhelming, right? That's where algorithms come to our rescue, acting as our digital navigators in the vast labyrinth of information and locations. From finding the fastest route home during rush hour to discovering hidden gems in a new city, these algorithms make our lives easier and more efficient. Route planning applications like Google Maps or Waze rely heavily on graph data structures to represent road networks. These algorithms consider factors like distance, traffic conditions, and even road closures to calculate the optimal route, saving us time, fuel, and frustration. Let's be honest, online shopping can be dangerously addictive, especially when those personalized recommendations seem to know our tastes better than we do. But have you ever stopped to wonder how these platforms curate such eerily accurate suggestions? Data structures and algorithms, my friend, are the masterminds behind those tempting product carousels. E-commerce giants like Amazon and Alibaba leverage sophisticated recommendation systems powered by machine learning algorithms. These algorithms analyze your browsing history, past purchases, and even items you've lingered on to predict what you might be interested in buying next. And let's not forget those targeted ads that seem to follow us across the web. Another example of algorithms at work using our data to deliver personalized advertising experiences. Section 5, from gaming to healthcare, algorithms at play. The reach of data structures and algorithms extends far beyond social media, navigation, and online shopping. These powerful tools are the backbone of modern technology, driving innovation and efficiency across a multitude of sectors. These concepts are transforming industries as diverse as gaming, healthcare, finance, and even space exploration. In gaming, algorithms are used to create realistic environments, enhance player experiences, and develop complex AI opponents that challenge even the most skilled players. In healthcare, algorithms are revolutionizing the way we diagnose and treat diseases. From developing life-saving medical imaging software that can detect anomalies with incredible accuracy to creating immersive virtual worlds in video games that provide therapeutic benefits, these digital tools are pushing the boundaries of what's possible. For instance, AI-driven diagnostic tools can analyze medical images faster and more accurately than human doctors, leading to earlier detection and better patient outcomes. In the rapidly evolving field of artificial intelligence, algorithms are playing a pivotal role in developing self-driving cars, personalizing educational experiences, and even composing music. Self-driving cars rely on complex algorithms to navigate roads, avoid obstacles, and ensure passenger safety. In education, algorithms can tailor learning experiences to individual students' needs, making education more effective and accessible. Additionally, in the creative arts, algorithms are being used to compose music, generate art, and even write stories, showcasing the incredible versatility of these tools. The possibilities are truly limitless, and as we continue to generate massive amounts of data, the need for skilled professionals who can harness the power of data structures and algorithms will only continue to grow. These professionals are essential for developing new technologies, improving existing systems, and finding innovative solutions to complex problems. As industries continue to evolve and new challenges arise, the demand for expertise in data structures and algorithms will remain strong, driving progress and shaping the future of technology. Section 1. Your secret weapon in the job market. Let's face it, college is not just about expanding your mind, it's also about preparing for your future career. And in today's tech-driven world, understanding data structures and algorithms is like having a secret weapon in the job market. It's not just for aspiring software engineers. These skills are in high demand across a wide range of industries. Imagine yourself at a career fair, resume in hand, navigating a sea of eager job seekers. When recruiters see proficient in data structures and algorithms on your resume, their eyes light up. Why? Because it signals that you possess the problem-solving skills and technical aptitude that companies crave. Section 2. Problem-solving superpowers. Data structures and algorithms are more than just technical concepts. They are tools for thinking, for breaking down complex problems into manageable chunks and devising elegant solutions. These skills are transferable to countless fields, from finance and consulting to research and development. Imagine yourself in a challenging internship, tasked with analyzing a massive data set to identify trends. Your knowledge of data structures helps you organize the data efficiently, while your grasp of algorithms enables you to develop a program to automate the analysis, saving time and impressing your supervisors. In today's rapidly evolving technological landscape, innovation is key. Companies are constantly seeking new ways to improve their products, streamline their processes, and gain a competitive edge. And who are they looking for to drive this innovation? Individuals with a strong foundation in data structures and algorithms. Now, imagine yourself as part of a team developing a new mobile app. Your understanding of data structures helps you design an efficient database to store user information, while your knowledge of algorithms enables you to create a seamless and engaging user experience. Section 4. Level up your college experience. Learning data structures and algorithms is not just about acquiring job skills. It's about challenging yourself intellectually, expanding your problem-solving toolkit, and gaining a deeper understanding of the digital world around us. It's about becoming a more well-rounded and adaptable individual, ready to tackle whatever challenges college and life throw your way. So, embrace the challenge, dive into the world of data structures and algorithms, and unlock your full potential. The journey may be demanding, but the rewards are well worth the effort. Section 1. The power at your fingertips. As we've explored throughout this journey, data structures and algorithms are not just abstract concepts confined to the realm of computer science. They are the invisible engines powering our digital world, shaping our online experiences and driving innovation across industries. From the efficiency of search engines to the personalization of social media feeds, these concepts touch nearly every aspect of our lives. Think about it. Every time you unlock your phone, order a ride-sharing service, or stream a movie, you're witnessing the power of data structures and algorithms in action. These concepts are the unsung heroes working tirelessly behind the scenes, ensuring our digital interactions are seamless, efficient, and engaging. Section 2. Embrace the challenge, reap the rewards. Now, you might be thinking, this all sounds fascinating, but isn't it incredibly complex? Yes, delving into the world of data structures and algorithms can be challenging. It requires patience, logical thinking, and a willingness to embrace new concepts. But trust me, the rewards far outweigh the effort. Learning these concepts is like unlocking a new level of problem solving. It equips you with the tools to tackle complex challenges, break them down into manageable steps, and devise elegant solutions. And these skills are not just valuable in the tech industry, they are transferable to countless fields, giving you a competitive edge in today's job market. Section 3, your algorithm for success. So how do you embark on this exciting journey of mastering data structures and algorithms? Start by embracing a growth mindset. Don't be afraid to make mistakes. They are valuable learning opportunities. Explore online resources, enroll in courses, and connect with fellow learners. Remember, learning is a marathon, not a sprint. Be patient with yourself, celebrate your progress, and never stop exploring. As you delve deeper into this fascinating field, you'll discover the power to create, innovate, and make a real impact on the world around you. Your algorithm for success starts now.